Okay. Hey, good morning and welcome to the Thursday session of Node.js Interactive. We're going to be doing a hands-on introduction to Kubernetes and OpenShift, kind of customized for the JavaScript audience. You can join us today at this URL, bit.ly/Node.js-on-K8s. So I would recommend everyone, if you have a laptop and you plan on following along, meet us at that URL. This deck of slides is actually using Reveal.js and a Node.js backend server. And I have a WebSocket relay that will hopefully, every time I do a page transition, flip your pages as well. So if everything works correctly, I'll drive and you all can follow along and copy and paste along with the examples. So hopefully we're all in the right room. Thursday, 9 a.m. This is the anti-serverless talk, basically. So I'm Ryan Jarvinen. This is what my avatar looks like online. You can find me most places as Ryan J on GitHub, Twitter, IRC, most places. I have with me today Jan Kleinert. Hi, Jan. We're both developer advocates at Red Hat. And we're very excited to introduce Kubernetes to this particular crowd. We'll start off with, if you're up for it, we'll try to get your arms moving a little bit. I would like to do a quick survey of the audience to kind of judge what your current level of experience is with Kubernetes and containers, and also to set some goals for what we hope to learn throughout this session. So first off, by show of hands, how many folks have experience using containers already? Wow, everybody here. Okay, well, most folks, excellent. So I'm probably gonna skip over the Docker build, Docker push basics and go right on to how do we use Kubernetes directly now that you know how to build a container. There's other topics on the basics later in the day, I think. Question number 2, how many folks completed all of the laptop setup tasks? That's about how many I expected, so I have a backup plan for the rest of you. So hopefully everyone gets to follow along. We've got a couple more seats up here for the folks who just showed up. Third question, how many of you have experience using Kubernetes? Anybody? Okay, less than the last one. These I'm kind of expecting a decreasing show of hands through here. How many folks consider themselves to be proficient with either kubectl or OC, the command line tools? So I see 2 hands, so hardly anyone. So hopefully by the end, I'll ask this same question, and I expect to see, if I'm doing my job right, 100% of hands go up by the end. So we'll see. Give me some feedback when we get to the follow-up question. So I'm expecting very few hands on this. How many people can name 5 basic Kubernetes primitives? Anybody? No hand. 1 hand. All right. Nice job. Okay. And this one, probably nobody. Do you have a plan for iterative, real-time, live development using containers? Because if you don't have a plan for that particular detail, it's going to be real hard to get JavaScript folks, front-end developers, to follow your lead on this. So we'll make sure that we solve that issue as well. So workshop agenda. We'll start off with this. Well, we're on the agenda page. I have a quick overview coming up soon. We'll cover the laptop setup, including what you would need to do if you wanted to follow along with these examples after the talk is over. For folks watching the video, we'll cover how to get started using Minishift to run everything all on your laptop if you want to follow along after the fact. We'll spend close to an hour on Kubernetes Basics, where you'll learn 5 basic Kubernetes resource types. And then we'll dive into more hands-on with OpenShift that'll cover a little bit more developer-focused use cases that OpenShift kind of adds to the mix. How to run builds on the cluster, some more sophisticated deployment mechanisms and automation around deployments, and how to share your success once you've really dialed in a working solution with OpenShift. How do you then package that up and share that with your team members so they're not forced to learn all of Kubernetes as a prerequisite? And then finally, I'll hit you with those survey questions again at the end. So at a very high level, Kubernetes is basically an operations tool. It exposes a collection of APIs that are designed to manage container-based workloads. You can click, if you want more information, click on the is, and that links through to the Kubernetes docs and a formal kind of definition of what Kubernetes is designed to be. And they have a section a little further down on the page that specifically declares certain things as out of scope for this project. Kubernetes has seen, the Kubernetes community have had some experience with open source before. They have seen a couple things suffer from feature bloat and scope creep, and projects expand to being unmanageable because they're trying to take on too much. So Kubernetes is really tightly focused as almost like the kernel of a multi-machine operating system. It's really focused on scheduling of workloads and kind of centralizing that management responsibility. And platform as a service style features, like a Heroku style experience, is kind of been declared out of scope for this particular effort. Another nice note along these lines, GitHub does usually does a yearly Octoverse report. So they had a report not too long ago, the most recent report, that listed Kubernetes as the #1 most discussed, more issue comments than any other repo on GitHub. So I think that type of metric alone hopefully shows that this is a project with a lot of user interest and a huge amount of adoption recently. There was, in the same report, another interesting fact: the #2 most talked about repo on all of GitHub this year was coincidentally also a Kubernetes effort, #1 and #2. So here's OpenShift and a little copy, cut of the top 10 most discussed repos from that article. But OpenShift includes Kubernetes as part of generally how Red Hat approaches delivery of platforms, of operating systems, as we give you a distribution, whether that's with Red Hat Linux, CentOS Linux, Fedora, CoreOS. We don't just give you a Linux kernel and say, good luck, you're on your own. There's user space utilities, login, system updates, package management. There's a whole collection of tools that go along with helping you be successful at using the Linux kernel. And OpenShift takes a similar approach, adding in multi-tenant security, platform as a service style workflows, service catalogs, container registry, distributed metrics and logs, a lot of stuff that normally you'd have to sign up for as extra cloud services that may have functionality that's specific to a single cloud provider. You can now have all of those cloud services represented via open source solutions, and that gives you the ability to quickly move between any cloud without having specialized functionality or custom functionality on a per cloud basis. So hopefully more flexibility and a distribution that will work equally well, not just on any cloud, but also on bare metal. So that's kind of our high level goal. Platform as a service style interaction for developers. And that's been our goal for more than 5 years now. OpenShift's been around longer than Docker and Kubernetes, and we've always tried to deliver a high-level developer experience throughout. So for more information, we jumped on the Kubernetes bandwagon very early. We're very involved in the community. I think Red Hat's one of the probably second leading contributor, depending on how you count contributions. We like to link people directly to the upstream Kubernetes docs when appropriate, and not duplicate concerns and documentation. So I've got links to the official Kubernetes repo where you can find releases and the official Kubernetes docs, along with all the source code for OpenShift and the OpenShift docs. So if you need more follow-up information, this hopefully gives you a lot of solid stuff to work with. So for today, your minimal requirements are basically to just have a web browser with JavaScript enabled. So hopefully you all at least have our minimal requirements for today. If you're following along after the fact, or if you did the lab prep, specifically these first three sections, then you can use your laptop instead of a web browser and follow these examples from your local machine. So I'm going to show you the web login, but you could definitely do this all from a terminal as well. So if you were following along later, I have a link to the Kubectl installation doc. For folks that have a bash shell, or bash compatible, I've have some one-liners that ought to allow you to copy and paste. Someone told me that the one of these one-liners is busted earlier, the Mac one, so I may have to go back. All right, well. There you go. So I know you folks all know your way around the command line, and if not, the install doc has some real solid advice. What we expect for today is a kind of a newer release of kubectl, probably 1.11 or better. And we'll have that already available for you in the browser. We'll also be using a tool called OC. This is basically meant to be a drop-in replacement for kubectl when you're dealing with some of the non-standard aspects of OpenShift. And so we'll talk a little bit more about OC, but when you're dealing with OpenShift clusters, you might need to use this OC command, at least in the short term, while we'll talk about it, yeah. We'll introduce this as well. Bash for Windows, if you don't already have it. I do some kind of a bash variable interpolation in these examples, so being able to export variables and use standard in, standard out is probably going to be useful for these command line examples. If you would like to run all of this demo on Minishift, I'm going to be updating the slide deck so that all the examples are just Minishift examples. So if you want to follow along later or fork the slides and repeat the talk, feel free to. Should be something you could do after as well. If Minishift doesn't boot correctly, click through on this installation guide for your virtualization driver plugin. This is usually, you just have to do this once, but Minishift will try to reuse your machine's virtualization solution. So if you already have KVM, Xhive, VirtualBox, whatever you got, you just need the right bindings for that VM driver, and then you can do Minishift start and specify which VM driver if you want to select a specific one. Once you get that all set up, using Minishift, booting up your own cluster should be as easy as Minishift start, Minishift stop to halt and reclaim your RAM, and Minishift delete if you want to remove the VM entirely. There's also a tool called Minikube if you just want native Kubernetes without the additional OpenShift add-ons. So they're both real solid, but since I'm doing a mix of both, I have Minishift for today. Well, we actually have a large large OpenShift cluster that we'll be using. So here is the main URL that I'll ask you to all copy and paste. If you want to use your laptop, you can skip this step. Or if you want to use your terminal prompt on your laptop, skip this step. If you want a terminal prompt that has all the shell utilities available in your browser, then paste this in, and let's see. You'll get a big, ugly warning. Sorry about that. Go ahead and hit Advanced and Add Exception. Sorry about this particular detail. We're using self-signed certificates, and oh man, all right. Got to it. Application is not available. Uh-oh. Okay. What's the other one? Terminal? HTTP only? No, it does need apps. We did test this before. Okay. Someone said it works with just HTTP? Okay. Maybe I'll skip the, okay. So I think the solution was change this from training terminal to terminal-terminal with HTTP, just HTTP. All right. How many folks need help with this step? Did everyone get the login prompt? You should have a screen that looks like this. If anyone not have this screen, raise your hand if you don't. All right, so for you 2 or 3 folks, on this slide, try copying this whole URL minus the S. Copy the remainder of this into up here. Leave off the S on HTTPS. It'll probably still give you that warning. You'll probably have to confirm a SSL deal because we're using self-signed certificates. I spun up this cluster yesterday and didn't pay for certificates. I spin up clusters for every demo. And we should be using Let's Encrypt to sign these certificates, but part of our deal is give you a cluster you could even deploy on bare metal. So we try not to make calls out to external services. But for this, I definitely think it warrants an integration. So for the login page, if you have a sticky, how many people do not have a login ID? Everyone has a sticky note? You have a login ID? You got it? Cool, everyone found it? You type in your username and then a password of OpenShift. So I'm gonna pick user 99. Anyone have that? No? All right, I'm taking it. It'll say you need to approve some permission deal. Allow state missing from cookies. Is everyone getting this page as well? Yeah? Oh, man, all right. Well, I have another cluster that we can use if this one's, did it end up spinning up later? So this is a new, we haven't tested this beyond, okay, someone's got it spinning up. What this particular app does is it launches containers on demand for everyone in the class. So what's happening right now is the cluster's trying to provision 100 containers all simultaneously for everyone and then fulfill the network request and give you a response. And it takes a little bit more time to have them spin up. So I would hit a refresh in a minute or two, and hopefully you get a valid response. And if not, you can always just use your terminal and use the exact same steps from your command line on your laptop, assuming you have OC and kubectl. So we'll give this a little bit more time. Yeah? Okay. Well, let me try that. User 99, OpenShift. thanks for helping us test this out. Sorry about the hiccups along the way, but hopefully this saves us 20 minutes or more of everyone setting up their laptop. So if this takes 2 or 3 minutes, we'll be doing pretty well. So, all right. So I have a login bash shell on my screen. How many folks have caught up to this point? Anyone have bash shells? That seems like half the folks here. I would try clicking on the OpenShift link in the top left and logging in a second time to see if that resolves your the terminal connection. I'll wait here for another minute or so. Hopefully everyone has this URL copied down. Let's go back to the terminal. Let's see. How's folks doing, Jan? How many folks, if anyone needs help at any point during this, feel free to raise your hand and we'll try to figure out if the rest of the crowd needs help as well. All right? How many folks are still stuck on this step? 1, 2, 3, so like four-ish. All right, not too bad. Most folks, sounds like they have a terminal. Cool. All right, so for the 4 that are still coming along, I would suggest the same type of deal. You can delete your username off the URL. And it should ask for another login if you don't have a current session. So Jan hopefully can help you sort out this step. But I've got most of the folks coming along for the ride so far. If you were using Minishift, you could use a command like this to export your API server variable. I'm going to take that line out, and we'll just run this next line, export API server, and here's the host address of the server that we're all going to be communicating with today. So I'm going to run this export command. Oops. If you're running Linux and Firefox and you have trouble pasting, I would try switching to Chrome instead. Because that one I've noticed does work well for pasting. And apologies again, we're using a kind of experimental setup today. But hopefully the goal is save us all a lot of time setting up our laptops. Okay, so next thing I'm going to run is I'm going to set up basically my user ID as a shell variable so I can refer to it later. I'm not sure if I don't think we actually use these, but I'm going to export them anyway just so we can refer to them programmatically if we need to. And then we're going to use the OC login command. This whole intro is all going to be straight Kubernetes with kubectl, but for this one command, we're going to start off with a OC login in order to configure our kubectl or kubectl file in our home directory. This is where your Kubernetes authentication credentials are stored. And by default, Kubernetes doesn't really have a integrated login utility. So we'll use OC login to set up this file. So you each have unique individual credentials on the cluster. So go ahead and run OC login with the API server and user ID that is on your sticky note, all right? Make sure you put in your own user ID here. So we're going to accept the certificate and use a password of OpenShift. And you should see a response that says login successful, now using project with your username in there. How many folks got that response? How many, actually, let me ask it a different way. How many folks did not get this? Anyone stuck? 1, 2, couple folks. What was your issue on this one?
I'm bringing it on my machine. I got error loading config file for 2 days. Get version time. It API version parse stuff. The config file looks like what you showed.
Okay, well, worst case, I wouldn't want to you to lose credentials to other clusters, but it sounds like you may already have a kube config file, and it might be, oh, really? Ooh, geez. Does it not have permission to write to that folder?
Oh, so like kube itself might not have permission to write.
Or if you're home direct, I don't know. Maybe you can't write dot files in your home? I'm not sure what.
The file exists, but when a OC login is failing, which is weird, go parse error. Not really sure why.
Anyone else hitting a parse error on their login? No? Sorry about that. I'm not sure. Definitely try the virtual terminal. Use the browser-based terminal if your laptop doesn't work.
Is that URL still available?
Yeah, we'll flip right back to that one real quick. Here is the training terminal and leave off the S, apparently. Okay. All right, so. Yeah. Sorry about that. I should have it be. It should be clickable rather than a copy and paste. Yeah. And leave off the S in the HTTP. Hopefully they spin up a little bit more quickly now that we got most of the load handled. All right, everyone set on this slide? Login. Anyone need another look at the login step? Next step is confirm that you're logged in by running OC who am I. And you should get back your user ID. Okay, here's our last checkpoint before we proceed at full speed ahead. So last command you're going to run is kubectl version. This ought to give you 2 responses from the API. And this is actually somewhat common for Kubernetes to give you a dual response from the API. Not specifically in this way, but we've got 2 responses here. One is the client version, and this is the version of the kubectl utility that we're using. And another one is the version of the Kubernetes API that we're using. So it looks like the OpenShift server is exposing Kubernetes 1.10.0 currently, and we've got a newer command line tool. There was a bug in 1.10 or 1.11, so I bumped us up to a newer version for kubectl. Anyone have problems? Did anyone not get a server response? Anyone not see server? All right, hopefully that means every 100% success. I'm going to assume it. I didn't see anyone complain. Okay, either that or folks have given up already. I hope not. All right, so let's go. You should, yeah.
I'm not the only one, so now I'm feeling bold. We're still at the cookies thing?
Cookies. Jan can help you out. Click on OpenShift in the top left, and then log in another time.
Log in another time.
Yeah, sorry about that. Yeah, this is the first time we've used this terminal, hosted terminal deal. Thanks to Graham Dumpleton for helping us set this up. So we've got 2 folks still working on their login. For everyone else, I'm going to move one step ahead, and we'll hope for the best for these folks. I'll stall for a little bit and introduce a topic called etcd. So etcd is a database. It's a key value store or a document object store that sits at the heart of every Kubernetes cluster. It's really designed around a couple specific use cases. This is meant to address a problem in distributed computing when you have a lot of machines that are spread out, and you update some application state on one machine, and suddenly this machine has a different state than the rest of the cluster. And you end up having a problem over time of just figuring out what's the cluster state, what's the real most recent cluster state, and how can everyone in this distributed system all reach an agreement on what is the current state of the cluster. And that's sometimes a real difficult question to answer. And etcd was really designed to kind of answer the question of what is our current cluster state in a distributed system. In order to address that question, there's a specific technical paper called this Raft protocol that's kind of designs the problem-solving approach that etcd has taken. And you could also look up this CAP theorem and see how etcd applies to this CAP theorem. I think it's a CA style database. But this is at the heart of every Kubernetes cluster. We're going to be shuffling some data in and out of this data store over the next section here. This is another key piece of kind of the architecture of Kubernetes is your ability to lose servers. Like if Amazon completely, it doesn't happen as often today, but they used to just randomly lose your servers. One would go missing. And if you had that type of scenario, someone trips over a power cord in the data center or any other type of loss of server functionality, what you can do with a solution like etcd is kind of decide what your desired fault tolerance is. If you want to be able to survive a loss of 4 different nodes and still have 100% capability on this cluster, then you would need an etcd with 9 instances in order to have full high availability and still be able to reach a consensus. It needs more than half of the nodes available for it to reach a real consensus. So this is more technical stuff. You guys won't need to get into this. But hopefully I've stalled long enough for our last 2 people to log in. Maybe? All right. Okay, great. So now that we've covered the data store, Kubernetes puts an API in front of that data store. If you had direct access to etcd, you are basically have root on the whole cluster. Being able to read and write the cluster state really means you have total authority on how the cluster should behave, and you can lie to the rest of the cluster if you wanted to. So, so the API provides authentication. That's what we did our login against. And what your kube config file is going to have your authentication credentials in there. Feel free to open up that file and take a look if you want to see the auth keys. As we interact with this API, we're going to see 5 attributes that are in common throughout each of these API resources. The first attribute that I want you to think about is a attribute called kind. This is basically the type of resource. It's called kind, but it's the class of resource that we're going to deal with. There's all data that you're using is independently versioned. So if you're sending an older data packet to a newer API, it could still handle it with the behavior that the old API had if it knows your data was spec'd for the old API version. So you can independently label your data packets with an API version as well. Next field is metadata. We'll see a couple useful fields in there. Usually there's some labels that you could use to run queries on the cluster. These last 2 are the most important. When I said that Kubernetes often gives you a dual response or 2 responses with every request, this is really what I was getting at. There's one field called the spec. This is what you say that you would desire to have throughout the cluster. And then there's another field called status. And that is the cluster reporting back to you on how much progress it's made in fulfilling your spec, right? And it may try and fail and then recover and succeed an hour later, depending. But anytime you update the spec, the API is going to respond in a very declarative manner to try to fulfill that spec. And it'll keep trying over time to achieve it, and it'll continue reporting back via the status field. And we'll see that this is mostly true for pretty much every API resource. If you want to see a very detailed and extended reference, click through on this API 1.12 reference, and you could get all the latest kind of attributes and resource types. We're just going to cover 5 today because we don't have a lot of time. So I'll kick it right off with step 1 is nodes. Let me get back around to this prompt here. So step 1, let's get into nodes. So I need to clarify for this audience in particular, in Kubernetes world, they have, I'm not happy with all their terminology. I'll point out a couple things that seemed strange to me as a new user. So number 1, they use the term node to mean a host machine, whether that's a physical or a virtual machine. It's where your containerized workloads are going to be run. Node activity is managed via 1 or more master instances. And usually you'd have 3 or more master instances hosting the API, and maybe 3 or more etcd instances for high availability of the data store, and then you could horizontally scale your nodes or worker nodes to scale out the cluster from there. So follow along and try to use kubectl to list resources by type. I'll warn you, actually, you should all hit an error at this step because you are all logged in as standard users. I'm logged in as an admin here, so I have permission to list nodes on the cluster, and you all don't. This is an intentional fail, just so we can try to get our demo fails out of the way early and move on to better examples. But here's an example of, I'm using kubectl get and then the type of resource in order to list API resources by type. Does that make sense to everyone, what I'm trying to do? If I wanted to run the exact same command using curl, I ought to be able to see a JSON representation of this output. Ooh, malformed URL. I didn't export API server. That's what this is. HTTPS master dot NodeJS int OpenShift workshop.com. Workshop. Aha, okay, good. Whew, it worked. So here's a response, much more verbose response, a lot more data, that's basically hitting the API using curl. And if we want to look into this path a little bit more deeply, API is the root of our API. V1 is going to correspond to the API version attribute I mentioned earlier, and nodes corresponds to the type of resource. So this is actually the path that we're going to hit on our etcd data store after the request goes through the API. So you can kind of see that represented in this curl request here. So observations from this section: Kubernetes is designed to exist on multiple machines. It's really trying to solve problems of distributed systems design. It's built for high availability and built for platform scale out. And also, terminology-wise, your JS runs on nodes, not the other way around. Next term we're going to learn here, there's a resource type called a pod. This kind of represents your minimum unit of scale throughout the cluster. So if you want to run multiple processes together, usually you run one process per container and link them together via this pod metaphor. Here's a kind of helpful rhyme that one of my coworkers, Steve Pusty, used to say all the time. He said, pods scale together and they fail together. What he meant by this is, this is an easy way. I usually think of this when I'm modeling my distributed solutions. So can anyone think of an example where you would want a front end and two pieces always linked together? Usually what I try to trick people into in this example is to say something like WordPress, where PHP and a MySQL, that's my WordPress, they need to run together. That's actually not how you would use pods, and the reason why is that you're gonna want to scale out your front end at a different scale than your database. You don't wanna add a DB every time you add a web front end. Architecturally, that's probably not how you want to scale that solution. So since those two pieces need to be scaled independently, they cannot be linked together via a pod. So for today, we're only going to have one container per pod. You could basically think of pods as containers for today. But if you did need to have a co-located process physically scheduled on the same machine, pods are your solution to achieve that. And that's often called a sidecar container. So these are examples you ought to be able to successfully follow along with. Let's all together try to list API resources by type. This is Node.js interactive. Let's do our interactive walkthrough. I'm going to jump back to the browser where I'm logged in as a standard user. And since we haven't created any data yet, get pods should give us an empty response. Get rid of this, okay. Next, I'm going to do I'm going to quickly look up this pod specification, so you can see what it looks like. This is kind of a minimal specification for creating a pod on a Kubernetes cluster. So some of the attributes we see in here, there's the kind or the type of resource, API version, like we said, was going to be included, metadata. Specifically in here, there's some labels that says run and then hello K8s. There's a spec that says what we would like in the cluster, and there's no status yet because the cluster isn't reporting back yet on how far along how much progress it's made. So let's go ahead and run this, the top line. Oops. This top line here, Coop Ctl create. If you want to use the curl example instead, you can pull down that file and I just run the second command, ought to do a curl example instead of a Coop Ctl. But choose one because you can't create the same resource twice. Next, we'll list our pods by type, and this time we'll use curl instead of Coop Ctl. This is just so you get a look at how to interact natively directly with the API in case you want to do some scripting from a Node.js app. So let's see, here is the API response. And wow, if I compare this earlier curl, and I'll pipe this into word count -L to count how many lines are in the original spec. We had 25 lines before we sent it into the API. And then after it came back from the API, now if I count the number of lines, we're up to 151. So this really grew. From the time we added it into the API, Kubernetes has done a lot of work to decorate this resource, mark it up, and add additional status and additional fields. So I'm going to take a look at our response here. I'll pipe it into VI. And so this is a pod list is our response. We did get objects by type. So we actually have this list wrapper. This is one of the few things that does not have a spec and a status. So I said it was mostly true. It still has kind, API version, and metadata, but it doesn't have a spec because the spec is an embedded list of items. So here's our next resource type. We have metadata. We have a spec. This is the pod. There's a lot more information in here. Metadata has really, now there's a creation timestamp that's been added. There is some resource limits that were automatically added. We're mounting in some service credentials to talk to the Kubernetes API. We're setting a random user to run this container as. There's a whole load of stuff. And then here's the status portion, where it's reporting back on how much progress we've made in booting up that cluster, or that particular pod. I'll run the same. This is what I'm looking at here. Any questions on this section? Did it make sense what we were doing? Listing objects by resource or by type. This one I'm fetching by type and by ID. So I guess I'll run this one more example. This is going to do the same thing as our last request, but it won't have that wrapper of a pod list. It'll just be a single pod item. Hello world. This should be hello K8s. Sorry about that. Yeah. We'll see how many of those we have to fix in the, but this is our single pod with our metadata, spec, status, API version, and kind all listed. And it looks like the API is doing a lot of work for you. The point I'm trying to illustrate here is you can start small with a very small spec and kind of let the platform do a lot of the heavy lifting. Once it's decorated this file and expanded it out, those are all of your fields. You have the opportunity to customize these resources and to tailor the behavior of how this object works throughout the cluster. So you could learn more by checking out that API reference link that I had earlier. So now we know how to list resources by type and by type/ID. We can request this same info, but then output the results as YAML instead of, and this should be hello K8s, output the results as YAML instead of JSON. So if you have half of your team is front-end developers who prefer JSON, the other half is back-end developers who write in Python, and you're constantly arguing over what format to, it doesn't matter anymore, the API will automatically translate on the fly back and forth between JSON and YAML. So you could standardize on both if that's what your team needs to do. Last example from this section is to use this kubectl Describe command. And again, I've got the wrong ID in here, but we can fix that pretty easily. And kubectl Describe has a little bit it's meant to be more human readable. Where human readable basically means tab separated, I think. But this has a less JSON-y, YAML-y output with a slightly nicer events listing. So you could see how the container was started up, whether there were any errors in that process. Sometimes it'll attempt to pull a container image, fail, try again later, and successfully be able to, you'll be able to see exactly what happened as parsed out of the status field. So observations from this particular section are that the API resources provide declarative specifications with asynchronous fulfillment of requests. So that's really kind of the details in this spec versus status fields, right? Another thing that you should note from this section, pods are automatically going to check process 1 within each container, and if process 1 fails, the container will automatically be restarted. And if you have 2 containers in a pod group and one of them fails, they'll both get restarted together. So as long as you have a single process per container, Pods do a lot of nice health checking for you along that individual process. Pods are scheduled to be run on nodes, and the API ambidextrously supports both JSON and YAML. Sound good? Hopefully that was clear from that section. Next item, services. So services they're meant to establish a single endpoint for a collection of replicated pods. So they basically, you could almost think of them as a load balancer. As a web developer, I often, when I hear the word service, I think web service, and I'm like, oh, that's my Node.js process, or that's Apache, or that's, that's a web server, basically. But in the Kubernetes terminology, service is a single network endpoint that will then fan out the traffic to a scaled set of pods. And we'll see some benefits on how this works. Which pods end up receiving the traffic depend on something called a label selector. And this is going to reference the metadata section of our spec files. So yeah, basically load balancer is the takeaway from this section. The spec is always, should be pretty consistent, but the implementation of a service may vary per cloud provider. You could configure Kubernetes to create an ELB if you're on Amazon for every service. On OpenShift, by default, we want to give you something that works out of the box, even on bare metal. So we include a HA proxy-based load balancer as our kind of default service type. Those come up real quick, and you don't have to pay for ELBs that way. So you could definitely opt in to whichever functionality you prefer in your cluster. It's kind of a decision of the ops team usually. You usually just create a service and accept the default, hopefully. Hopefully you don't need to customize it too much. So let's take a look at some examples using services. Now that we have our container, and I still have hello world in here, it looks like my search and replace didn't fully hit the whole file. So we'll have a little bit of, you won't be able to copy and paste every step. You'll have to do a little bit of editing, so apologies for that. Let's go back to hello K8s, and we'll run kubectl expose on this resource type and ID. We're going to use this -- port flag to identify what port the container's running on, and we're going to use a type of port that is the node port style. This is basically the simplest, most primitive service type you can use in Kubernetes. And the reason I'm using it here is because it will work, it's guaranteed to work with mini shift and mini kube. So for folks that are following along later on their laptop, this will work for them. And I'll have the URL, the resource ID will be fixed to hello K8s if you follow along later. So if you run that command, you should see a response that says service/hello K8s exposed. If you're wondering what K8s stands for, 8 is the number of letters between the K and the S in Kubernetes. So that's kind of shorthand that some folks use. So let's take a look at the resulting spec and selector attribute in this resource that we've just created. So this is hello K8s. We're doing -o JSON. We see there's a API version, a kind, a metadata, there's some labels, there's a spec, all things that hopefully by now you expect to see. And there's this field called selector. Selector has this pair in here, run hello K8s. If we take a look at our pod, we look at pod hello K8s -o JSON, and let's just take a look at the top. So, oops, let's get a couple more lines. So you could see at the top of our pod, there's a metadata section with labels, and a section that says run hello K8s. And then the service had this selector set to run hello K8s. What the service is doing in order to figure out where to direct its traffic is it's querying the Kubernetes API with this query selector. Let's do that query selector manually next. First, we're going to find the exposed port number and verify that our application is available. So I'm going to do kubectl get service type, service ID, where we have a new -o option. Make sure to fix the resource ID to hello K8s. We'll add -o JSON path in order to select a specific field out of the response. And what we're looking for particularly is the port number that this service is running on. Node port will expose each application on a different port on the cluster. So it's a pretty primitive way to route traffic that's kind of a little bit brittle because you're targeting specific ports. So now we can contact that application using it's hello K8s. Got to make sure everyone's paying attention at every step. Okay, this should be your resulting URL if you would like to click through and run the same command in your browser. You should get your own port number added on. And let's see, let's open this up. So you should see something like this, hello Node.js interactive. Anyone get something different? Any errors on this step? Okay, no complaints. Hopefully that's good news. We could run the same thing via curl pretty simply. So I'll just do that example real fast. Here's our HTML source. So it looks like we have traffic routing into this one container. We're starting with very small building blocks and then building up from kind of the most primitive resource types up to higher order abstractions that make all of this easier to use. So we're kind of slogging through the difficult bits now, and hopefully this gets a lot easier by the end. You will have to stay awake and update the resource IDs to match. So let's run a get pods, and now I'm going to use a -l run equals hello K8s. So let's do -l is going to run a label selector query on the API. This is the same command that the service is going to use to hit the API and figure out where to route traffic. If I were to edit this pod and remove the labels, no traffic will flow to that pod. Traffic will cease to flow to that pod. So you could take it out from behind the load balancer by relabeling it. Let's see. Let's go ahead and delete our pod in order to really clean it out from behind the load balancer and to force an error. So I'll run hello K8s. I'm going to delete everything based on this label selector. Let me move this, get the terminal a little higher up on the screen for you all. So I should have a pod being scheduled for deletion. Now if I contact that same app again, I'm not getting my terminal back. Here we go, break. I copy do the same, oh, it didn't finish my delete. Okay, all right. Okay, so I'm getting an error page is the response here instead of a hello Node.js. Should be able to verify that by reloading this one. Yeah, site can't be reached. That looks about right. It's because the service does not have any pods to route the traffic to. So we expect this type of deal. Now that we've broken our service, let's clean up the service as well. We'll run a Coop Ctl delete with a resource type and resource ID in order to clean up our service. And it's hello K8s instead of hello world. Any questions about that section? No? Okay, here are your takeaways. Service basically means load balancer. Label selectors can be used to organize workloads and give you an easy way to do bulk operations on the API. You can match a lot of things with a label selector and kind of perform operations in aggregate. The service resource uses these label selectors to discover where traffic should be routed, and pods and services don't share any lifecycle. You can delete a pod and still have a service, or you can have a service or a pod with no service at all that's not even routable. So these really have disjoint life cycles and are not managed as a pair usually. Next topic is deployments. Deployments help you specify container runtimes in terms of pods. So let's run our first example here. We're going to run a kubectl run command. We will pick a name for our container, and we will set the image to Jan's demo image she built earlier. And then we'll do --dry run -o JSON. And we're going to pipe the result into a new file called deployment.json. And I'll explain what we're doing in a second here. Deprecated and will be removed. Ooh, okay. Warning, deprecation warning, be aware. All right, so let's see what we ended up with in our deployment.json. So we have a kind. It's a typed resource. We have our API version. We have a metadata field. We have labels, all things we've seen before. Creation timestamp has not been populated yet. The spec says we want one replica of this service. It has a selector in here that's used at some point, and then it has this template field. Does anyone recognize what's going on inside this template? We have metadata, we have spec. It kind of looks like an embedded resource, right? This template field is actually a pod spec, and when we did that kubectl create on our pod.json earlier, this is actually where I got that pod.json from. I copied out the stuff from this template, and I added in the kind of resource and API version v1, and that's about all I needed to do to generate a pod spec. And what the deployment is going to do is it's going to look at our replication count. It'll look in the spec, and if the spec says replication should be 1 and our status says we're currently at 0, then it's going to use this template in order to create new pods on the API. So now that you've seen how to create one pod manually, never do it again. Now you know the better tool is to use deployments, and deployments will create pods automatically. Whenever a pod goes missing, you'll get more pods, and it'll just keep repairing things no matter how many pods crash. If you have replication set to a higher number, you can have high availability of your workloads and then do rolling deployments and other things without loss of service. So that's basically, yeah, you want to know that the pod spec is basically embedded in a deployment spec. Let's run the kubectl expose command instead, but instead of exposing a pod and a resource ID, we're going to expose the deployment. Deploy is shorthand for deployment. You could use either one, but kubectl expose deploy, we're using our node port type. We're using a port number. I've added on this dry run flag and -o JSON again, just like in the above example. What dry run does and -o JSON, what this is instructing kubectl to do is it tells kubectl, I want you to generate all the JSON, but don't send it to the API. Just write it to standard out instead of initting a new object or a new resource. What this allows you to do is have a real sane starting point. If you are the type of person that wants to edit this JSON and make customizations, you can run kubectl expose -- dry run to get a raw spec for your services. And you could do dry run on kubectl run in order to generate new raw deployment resources. So dry run is really useful if you just want to generate a spec file that can be used later. Did I ran the cat deployment. Let's do the same service example. I'll do the expose. I need to check the resource ID and make sure I'm staying awake for this demo. Hello, what was it called? It's called NodeJS int. New name, all right. Okay. So it'll teach me not to do a bunch of search and replace on my demos before rolling them out. So run NodeJS int. And then this one should be called expose deploy NodeJS int. That looks pretty good. No? Okay, we did a delete. I think this error is okay. It's saying we can't find a deployment, but we haven't created that deployment yet. We've only created a spec file. So I'm going to cat my service.json, no file yet. I'm going to rerun that command after we let's create our deployment. So we'll run kubectl create -f deployment.json, and this allows you, if you want other people to spin up a specific deployment, this is how you can hand them a JSON file with the deployment source and say, here's how you onboard your new team member. Get ready, one command gets you up and running. So we'll run that kubectl create. Now we should have a deployment with that resource ID, NodeJS int. Oops. And I will generate the service. Now we should be able to list that service file. And now we know how to create a service as well. You can also create, you can do kubectl create on both files at the same time by doing, using to -f. -f is for file input. You could also specify remote files, like a file on GitHub or somewhere over the network. You could also specify a directory if you want to pick up all the JSON and YAML files within a current directory. So you could have a folder called staging that has a whole bunch of resources, and then you do kubectl create -f on the staging folder to launch your whole staging area. Now let's do a listing multiple resources by type. This time we're going to comma separate multiple types in order to grab several different resources from the API. So we could see we have a pod and a deployment. And there should be, I haven't created the service yet. Let's do kubectl create -f on our service.json file. Now we should have all three in our response: pod, service, and deployment. Lastly, we can connect to this new app and verify that, let's see, is this possible? It doesn't look like, I probably need to fix this identifier and change it to, oops. This needs to be Node.js int. Okay, and now we've got our response, our hello world basic response from the API. Let's see, next step, we are going to scale up our app. The simplest way to scale up a deployment is to use the kubectl scale command. We're going to start easy and then go to some more advanced ways to do this. So I'll run kubectl scale with our Node.js int resource type. We'll set the replica count to 3. We got a response saying our resource was scaled. Now if we do kubectl list resources by type of pods, you could do PO for shorthand. We have 3 up and running, and you could see based on the age, 1 was launched with the initial deployment, and 2 were launched more recently as the result of my scale operation. Now, if I wanted to, here's a real fancy trick. If you are afraid of using VI, skip this command. If you don't mind using VI, go ahead and follow along. So Node.js, and this is really ought to use whatever the default editor is on your machine. If you're using this interactive web browser, I only have 1 editor installed, so sorry, VI is your only option today, but I'll tell you which keys you need to use. So if you open up this file with VI, you can type in /replicas in order to find the replicas field. We'll arrow key over to the number, and I'm going to hit the letter S for substitute character, and I'm going to change this to a number 5. And then if you're not up to speed on how easy VI is to use, you can hit escape :WQ. It's that easy, and that'll write this file out and save it and quit. Normally, VI is going to save to disk. Where do you think this is going to save to? This is actually going to write it back across the network and rewrite our spec on the API. So the edit command should use your default editor, whatever it is, and give you a way to manually edit the JSON that exists in the API. I do not recommend manually editing this stuff by hand, because you could probably break things, but if you really needed to get to it, this is one way to get at the low-level details, especially as you're just learning Kubernetes and you really want to sculpt this stuff. I really start thinking of this as like a distributed systems modeling language, where I'm hooking together all these different pieces, and the edit command gives me a nice way to really get my hands dirty. Now if I list pods again, we should see that we're scaled up to 5 pods. Looks like 2 are still in the process of creating, so I don't know, we may be maxing out our cluster. We've got a lot of users on this one, so we'll see how quickly those 2 come online. Now I'm going to do another command. We can run get pods with this -- watch. And this runs the same command, list resources by type, but now it's going to leave the connection open, and anytime there's an update of a new pod on the API, this is going to get a WebSocket event that's going to print the new pod name. So we should get like a rolling dashboard of new pods. Next thing I'm going to do is I'm going to run a query to fetch a couple random pod names. I think I have hello world in here, and we're going to need to change it to Node.js int. But this should get the names of 3 random pods. So I'm going to run this same command. I'm going to wrap that same command with kubectl delete pod, and then do a subshell to pull out those 3 pod names. And so this should kind of give us like a shotgun blast of damage across our collection of pods and delete 3 out of our group of 5. And let's see what the API does. The spec is set to 5, and we're going to artificially push the status out of alignment. Right now, I should have a spec of 5 and a status that also says 5. We may not have achieved it yet, but that's how things should be going at this point. So I'm going to run delete, and we immediately see that watch operation is streaming back updates from the API. And as quick as we can delete them, or as quick as they go missing, for whatever reason, the API will notice this issue and redeploy that container onto other available nodes. If a node drops offline, we'll automatically reallocate all of your cluster resources to other available machines. Any questions on that particular section? No? All right. We'll have time for Q&A at the end if you have follow-ups. What happened? How many pods remain? Hopefully you have a good list of 5 pods by the time you run the get pods command. Observations from this section are you can use the -- dry run flag on almost any command to generate raw resource specifications that you can use later, right? Then you could kubectl create -f on that raw resource. So if you need to customize things before sending them to the API, dry run gives you a look at the raw JSON or YAML, so you can do that additional customization. Deployment spec contains a pod spec in its template attribute. The API provides edit and watch operations in addition to the get, set, and list operations we've seen earlier. Does this make sense? Everyone good so far? Cool, all right, awesome. Our last section, and I'm gonna speed through this one because we're running late on time, is replica sets. Replica sets provide replication and lifecycle management for a specific image release. This should sound almost identical to what I said regarding deployments a minute ago. So let's view the current state of our deployment. I'll run, let's see how bad this URL is. Node.js int, we'll just change the service name to Node.js int. We got our hello Node.js interactive. That's looking good. I'm going to foreground our previous watcher and kill it and then start a new watcher. You can use -w instead of --watch if you want a shorthand command for doing watches. So I'm going to watch our deployment. This is going to give us the name of our deployment, a count of how many we are currently desiring, what's our spec field, spec replicas, what's our status replicas, how many of those replicas are currently up to date, and how many of them are available. So this should be a nice dashboard. As we do a rollout, we'll be able to see how much capacity we're successfully able to serve at any point. I'm going to run this set image command in order to reconfigure the deployment with a new image release. Node.js int. This one is also, I believe, Node.js int. Let's see. And this is Jan Kleinert. Yeah, this is. Oh, that's right. Okay. Yep, J Kleinert and Hello Workshop. Okay. Looks like something's happening. We have our desired is still set to 5, but the number in circulation has now boosted up to 7. This is how many are active and how many are current. So we can then, I wonder if that is a successful roll forward or not. Let's get our replica sets and see what's going on at this point. So it looks like we're midway between. I probably have a bad image name, but this example will still work perfectly because our next step is to do a rollback. So either way, this is a successful demo. I'm going to take credit for it. We have two replica sets here, Node.js int, and then some big string here. And you could see that one deployment is like midway through completion, and it's hit an error. This happens sometimes, and you could basically, when this works correctly, the way this will work is Kubernetes will start relabeling the pods that are under replica set 1. So that'll start with 5 replicas, and then it'll bring on a new replica set for the new image, and then it will scale up. Once this is up, it scales this one down, scales this up, down, up, until we have all 5 successfully labeled behind the service endpoint. And so it'll rotate these pods out of circulation and try to maintain a certain amount of service availability throughout. That's why our deployment has stalled, is because the new replica set isn't coming online, so it's halted the progress of the deployment. Next, I'm going to do rollout history in order to see what we've done so far with this deployment. So it looks like we have 2 revisions so far. I'm going to do rollout undo. Rollout undo, and this is deployment, Node.js int. And this should roll us back. And since I still have that watch thing running, we can see our deployment readjusting, resetting the spec, trying to get back to 5 that are in circulation, 5 that are up to date, and back to a sane point for our current deployment. Looks like still only 2 available, so it may have halted at some point. Next step is to do a cleanup regardless. So let's go ahead and hit this. We're going to do a delete of a service and of a deployment. So we're deleting 2 objects by type as long as they share a single ID of Node.js int. Let's see if that works. We got one of them. Is the service named something else? Coop Ctl get services. No resource. Huh, okay. Well, I must have skipped a step and failed to create the resource or something. You can do a final step of kubectl get all in order to see what's remaining. It looks like I have 2 pods that are stuck in a terminating state. I can do delete pods with the 2 specific resource IDs, or I can try another. Careful not to do this when you're logged in as an admin, because you can wipe out the whole cluster. But let's do delete all -- all. And that should delete all resources of all types. And hopefully you noticed if we start by deleting pods, the replica sets automatically make new pods. If you delete the replica sets, deployments automatically make new replica sets. If you start from the top of the chain and delete deployments first, then you can work your way down the stack, and deleting a deployment ought to clean up all the pods as well. We got a couple stuck ones, but it's a distributed system, and it's designed to work around errors, so let's do that. Observations from this section: replica sets provide the real lifecycle management for pod resources. Deployments create replica sets to manage pod replication throughout a rollout or throughout a specific image release. So you have kind of stacked deployments, replica sets, pods, all of those running on nodes. All of them scheduled on Kubernetes. If you are really interested in just sticking with only pure Kubernetes and not using OpenShift at all, I did a talk at KubeCon on how to use Minikube for local development. Here's a link to the video. If you're interested, click on through on that after the workshop. For now, I'm going to show you, in the remaining time, hands-on with OpenShift. So I'm running short on time, so I'm going to go through as quick as I can. Step number 1, we're going to build a new image, and we'll go through the web-based create workflow. So to get to this URL, let's see, it should be in the slides. No, it's not in here. All right. So if you are currently logged into this terminal, you can copy, you've exported it. Let's see. All right. Echo, what did I call it? API server. This address. Copy and paste this address into your browser. Go ahead and accept the self-signed certificate warning and log in using your user ID and password. And you should be presented with something called a service catalog. Anyone need help with that step? It should be the API server variable from your shell. The same thing we did OC login against earlier. So you should get this windowed kind of dashboard. Let's take a look at the dashboard and do a quick create, build, deploy of a Node.js application. So I have a demo app called HTTP base. The instructions here say to fork the repo onto GitHub. That's so you could have control over the webhooks. Since we're short on time, we'll skip over this step, and I'll show an alternate way of updating our deployment. Ideally, what we would set up here is a callback from GitHub back into Kubernetes. So anytime we do a git push, we'll get a webhook that fires into OpenShift. That'll automatically trigger a new build and a new deploy. So you get that Heroku-style git push to deploy. And that's really useful for sending things into your release pipeline, into staging or whatever else, into a CI test. So I'll copy this repo folder, get us back to the terminal. I'm going to start with browse catalog. I'll search for Node.js. I'll pick the Node.js runtime. This is designed to be basically, there's no expectation that you know what a container is, what a pod is. You select which project you want to add it to. You select your node version. I'll show you how to get Node 10 later. We'll put in a application name of HTTP base and a Git repository field with this HTTP base. If you have another repo that listens on port 80, you might be able to paste that in instead, but this is hopefully a known working example. We'll see how it goes. So now that we have that loaded, I'm going to jump into our project. If you want to see metrics, you can click on another certificate. We got a lot of these self-signed certificates. Then you could refresh, and you should get some integrated metrics into your web view. Looks like we have a build that's failed, so should be able to go in and view the log. Couldn't find the repo. I need HTTP in front of it. So luckily, we've got a nice web-based UI. I'm going to fix this up. I'll edit the YAML and change this to HTTP. Sorry to kind of speed through this step, but you could rerun it with HTTP in front, and it should work. So that should update our build config. Build configs help us run builds on the cluster. I go back to our list of builds. I should be able to kick off a new build. And let's see if this one runs any better. I'll click through on the build. We can watch these logs as the build happens. It'll stream our log feedback into the terminal, or into the web session here. And you could click on follow if you want to stick to the bottom of this and watch the build happen. So this will do npm install, bring in all your npm dependencies, add your repo into on top of a set of base layers of a Docker image, and then push the resulting image into a integrated container registry. Once that push is done, a new event will fire saying, image has arrived in the registry. Kubernetes will get an event notification and automatically schedule a new deployment. So we already have our deployment rolled out. So our inputs here were what language are we working in and what repo are we working with. I kind of fudged that one a little bit, but now that we have it in there, those two inputs and my response is, here's a host record, a host URL that you can now target, or even point an integration test towards the result, right? So hopefully you are able to find a URL like this. If your build succeeds, create a second build if you need to. So this should be the success case for the create workflow. Let's do a quick check from the command line to see what's happened. So I'm going to flip back over to the command line. I'll paste in a OC get pods. I'm switching over to the OC command line at this point because we're going to deal with a couple non-standard OpenShift resource types. So here's our list of pods. Let me run Coop Ctl get pods, and let's see what's the difference between these commands. Ideally, no difference at all, right? OC is really designed to be a drop-in replacement for kubectl. It's more of a stopgap mechanism just to hold us over while we take our non-standard pieces and move them into a more formal extension system called custom resources. Once we get everything moved into custom resources, we may be able to deprecate OC potentially and just use the standard kubectl tool. But for now, where we're at architecturally, you need to use OC to get visibility into our custom resource types. But ideally, same output, but additional visibility to those non-standard resources. Next, we would demo this git push to deploy. I didn't do the we didn't do the fork on GitHub, and we didn't set up the webhook, but you should be able to clone your own fork or my fork, step into this repo. This would be I'll copy this into my shell. I already, actually, I'll do it inside this environment. I'm gonna git clone git at github.com, Ryan J. Base. Let's see. I'll change it to HTTP. And / All right. So this should give us a local repo to work against. If you accepted the metrics warning, you should start seeing some performance metrics piped into your dashboard here. I got the HTTP base command. We could set up a webhook so you could do git push to deploy. I'm going to skip past that. Instead, I'm going to show you something that I think is even more powerful. This is where I think front-end developers, Node.js developers are really going to start to see a lot of value out of Kubernetes. If you're a front-end person, a lot of what I've covered so far may be stuff that is outside of your scope of responsibility. If you're doing just HTML and CSS, that stuff scales pretty endlessly just in an S3 bucket. You rarely need to spin up, horizontally scale little pieces of things for a front-end experience. But once you do a lot of microservices that need to be scaled independently, this really adds a lot of power. And what you need to use it for local development is the ability to achieve this kind of live development, real-time development loop. So I'm going to quickly try to do a quick demo where I show this working. And let's see, I'm going to find out what my pod name is. So here's the pod that is currently deployed. And I checked that we got a hello world page. I'm going to run a command called ocrsync. What ocrsync is going to do is synchronize the local clone I have of this repo into the remotely running container that's hosted in OpenShift. This potentially allows me to standardize my entire development stack, put it all in a container, and onboard new users by just saying, hey, do a git clone locally. The Node.js version, we've already hosted in a container. You don't have to set Node.js up on your laptop. You don't have to set up Grunt. You don't, like, your laptop install is 0. It's just git clone and then synchronize your repo, and you could spec out the remaining requirements on the cluster. So let's synchronize our local repo with the remotely running repo. I'm getting some minor errors here, but that command will basically accomplish it. I'm going to run a minor change to our index.html just so we can observe the change, and I'll say, let's call this Node.js on K8s. Oops, that was in the, well, it's in the, yeah, let's see. And then I'll rerun this sync. You should be able to add a -w in order to continually watch your local disk for changes. I'm hitting an error here, so it's killing the watcher. But what this ought to do is allow me to have a real-time development loop where as soon as I write to a file, I hit save on that index.html, I hit reload in my browser, and I can immediately see my changes. If you can't do this with Kubernetes, you're going to definitely see some struggles getting your front-end developers to try to adopt a platform like this. So I think this is a really critical piece. Being able to successfully synchronize content and to be able to standardize the whole dev stack gives you a lot of power. The other thing I can do with this, if I'm doing real-time development against one microservice, I can pull down a collection of other microservices from my staging area and potentially do an integration test before I make my commits. Usually I would have to make a commit and push to my, integrate it to my dev release pipeline in order to get that type of feedback from a functional evaluation. Now I can pull down images and do a functional integration test before I make my commits. And that's potentially revolutionary, I think, for people who are doing distributed systems and microservices development. So this would be one command to get it done. We also have a command line tool called odo, and you could do a simpler odo watch shorter with odo. Stop by the booth and ask us if you want more information on odo. Last things I'll show in this section, terminal access. If you wanted to shell in directly into a terminal, here's my bash prompt. I can do ls, I'm inside. Let's do ps list all processes. It looks like PID1 is npm, so I'm definitely in a container. I didn't even hit my OS init system or anything. So I have full access to the shell here, and I can run curl against the service name, and anytime you create a service, inside the cluster, there's something called kubedns that will match up the service name and make it resolve via our local DNS. So I could do curl service name, and it should allow me to target, 8080, there we go. We got our response. Okay, and last thing, there's also from the web console, I can click on this pod and get an interactive terminal right here. I mean, it's not a good idea, but I could directly edit the index file in case I'm doing some debugging or something, but you don't want to introduce a lot of statefulness, a lot of changes inside your container. That should be happening in your Git repo. But the idea here is I can preview my changes and test them without having to stop to do a git commit or a Docker push or anything else. I have a tight, fast development loop. So hopefully that is obvious from this demo. You can do additional configuration, like setting environment variables. Config maps and secrets are also something you could use to inject in configuration. OpenShift is going to bundle things like distributed logging and metrics aggregation. You can also get these type of services from your cloud providers, but it's nice having them solved using all open source solutions so that your logging service is portable to any cloud, and you could run in a consistent way on any cloud, including bare metal. You can customize the deployments to do different styles of rollout. There's some notes on deployment strategies in that behind that link. Last thing I'll do to kind of summarize is now that you've learned all of Kubernetes, 5 basic points from Kubernetes, and you've learned a little bit about what OpenShift adds, this is one more piece that we add. There's something called Open Service Broker API. This is an effort that has a standard API for a front end of a service catalog and a standard API for a back end service broker. So we've been using with OpenShift this OpenShift template broker, and I'll, if I have time, show one more example of this. But you can also hook up additional backends, Ansible, Amazon Web Services. There's a nice new AWS service broker that allows you to populate the service catalog with everything that AWS offers, and then you can kind of order it a la carte through this interface and have your ops team give you credits or, I don't know, help manage that relationship. So this is designed to be everyone's service catalog, not just OpenShift, but also a standard for Kubernetes and Cloud Foundry. And there's even a Helm chart broker. If you wanted to install Helm charts, there's a broker for that. You can also use our template metaphor as an installer. If I had a template.json, I could run oc create-f to install that template. And let's see a quick example of that. I'll do oc create-f on this long template file. Oc command not found. Oh, I'm still inside the container. Okay, oc create-f. This will add in a new template. You could also customize your base images if you really want to extend the experience, add in things like crypto libraries or other details. Let me really quickly show this last example, and then I'll wrap it up. So now that I did that OC create, I should be able to go back to add to project and select from my current project. There's now a new installer option. This National Parks, Node.js, and MongoDB. This is actually a full stack. This is a Node.js process with a build and a repo and a service and a MongoDB database and a Java Docker image that's deployed. It's like a whole collection of microservices that I can spin up all in one go from the web. So if I had a very complicated environment that I would need to onboard new team members, I can basically add a launcher in the service catalog that they could click through and reproduce everything that you have learned throughout this workshop. So hopefully this has been useful for you. To wrap up, I'll note that we have a couple O'Reilly books here. If you are interested in an O'Reilly book on OpenShift, come up. We've got a stack of them near the stage. I have a summary of kind of Kubernetes terminology that hopefully you've learned, and another summary of some of the OpenShift terminology if you want to dig in deeper on those aspects. More ways to try OpenShift. We've got an interactive learning portal, learn.openshift.com, that gives you kind of a OpenShift in a browser. So you could play around without any login, or it boots up a VM for you and gives you 1 hour for free. If you want to run everything locally on your laptop, try out Minikube or Minishift, and I'll revise these slides after the fact, so get all the IDs corrected and everything working for mini-shift environments for folks who want to follow along later. Lastly, we have tools for this community specifically. There is a REST client called on NPM called OpenShift REST client. This knows how to talk to the OpenShift and Kubernetes APIs. So that's a nice way if you want to programmatically access the APIs and don't want to write your own client for that. There's one ready to go. There's also an NPM module called NodeShift that will generate your deployment, your builds, your pods, your services, everything you need, so you can just run npm run NodeShift, and it all gets deployed to an OpenShift cluster. So that's another really easy way to init projects. If you want access to Node.js v10, check out this repo. There's notes on how to install that into your cluster. And I think that's about it. If you have more questions, find us in the booth. How many folks feel like they have a basic capability with OC and or kubectl? Do folks feel like they got a decent intro? That's pretty solid. Thank you. Thanks for following along. Hopefully this has been educational. We'll be in the Red Hat booth. I'm Ryan, and this is Jan. Thanks again.